This is a second video about chemical bonding, and in this video we're going to start drawing Lewis structures. But first, let's just review what a chemical bond is. Remember, it is what holds atoms together in a molecule. Now, when we have a chemical reaction, bonds in the reactants are being broken and then bonds are being formed in the products. These chemical bonds are made up of the outermost electrons in the atoms, which are called the valence electrons. We talked about three types of chemical bonds: ionic, covalent, and metallic. Ionic bonds are between a metal and a nonmetal, and the electrons are transferred. That's the important word. They're transferred from the metal, so the metal loses the electron and it's a positive charge, and then the nonmetal gains that electron and it has that negative charge. Then those opposite charges, that's what holds the cation and anion together, and it forms the ionic bond. So an ionic bond is made up of opposite charged particles, and it's called an electrostatic force. Now, physical properties of ionic compounds. You need to know this. Ionic compounds, most of them are crystalline solids at room temperature. So think about things that we know, like sodium chloride. That is an ionic compound, and it's a crystalline solid at room temperature. They generally have very high melting points, and when you do melt them, they can conduct electricity because they have ions in them. So in the melted state, they are electrolytes, or if you dissolve them in water, they can make ions and they are electrolytes. Metallic bonding is when the valence electrons are just free floating or they're delocalized above a metal. And these electrons stay around that positive core of the metal. And of course, metallic bonding is used in metals. So let's review physical properties of metals. They're good conductors of heat and electricity. These delocalized electrons, is what is responsible for these properties. They are ductile, which means you can draw them into wires, and metals are also malleable, which means you can pound them into different shapes. All right. Metals can form something called an alloy, and that's when you have two or more elements combined, but one of them is a metal. Now, the properties of alloys are usually better than the properties of the elements alone. Some common alloys, now you don't have to have these memorized, but this is just kind of an FYI. Steel is iron, and it has carbon, and other elements are possibly in them, like chromium or nickel. Sterling silver is silver with some copper in it. The silver by itself is really soft, and you could just bend it. So they add some copper to make it a little stronger so you can wear it for jewelry. Bronze, if you studied the Bronze Age in history, that was when they started really making some good tools. There's copper and tin in bronze, and brass is copper and zinc. So let's talk about the covalent bonding between nonmetals. These are when electrons are shared. So for the rest of this video, we are going to draw the Lewis structures of the diatomic molecules. So let's start with hydrogen. All right, hydrogen, H2, one of the diatomics. And so each hydrogen has one valence electron. Now, most atoms want to have 8 electrons in their outer shell, but hydrogen is the exception. It can't hold 8, so it would like to have 2 valence electrons in its outer shell. I like to say 8 is great, but 2 will do for hydrogen and helium. All right, so this hydrogen and this hydrogen, if they would share their electrons, they would each have 2 electrons in their outer shell. So see how this hydrogen has 2 electrons, and then this hydrogen has 2 electrons. Those electrons are shared, and that is the covalent bond. So this is and it's just a single bond. It's a single covalent bond. Now, some people will draw covalent bonds as 2 electrons because that's what it is, but the more common way is to see just a dashed line. So that single line there represents 2 electrons that are shared, and that is our covalent bond. That's the Lewis structure for H2. Now let's look at chlorine. Chlorine is a halogen, and it has 7 valence electrons. And here's another chlorine. Okay, each of these chlorines would like to have 8 electrons in their outer shell, so they would need to gain 1 more electron. And so what happens is they share these electrons here. And so we get something that looks like this. And here's the shared pair of electrons. And now see, this chlorine is happy. It has 8 electrons in its outer shell. And this chlorine has 8 electrons in the outer shell. Here is our single covalent bond made up of 2 electrons that are shared. And so that is our covalent bond. We could have drawn it like this as a dashed line. And again, that dashed line represents 2 electrons, and that would be Cl2. Now these electron dots out here, these valence electrons that aren't involved in the bond, these are called non-bonding electron pairs. Okay, some people call them lone pairs because they're not shared. Okay, but they're not involved at all in our covalent bond. All right, now the other diatomic molecules. So we did hydrogen, and now we've done chlorine, but there's bromine, and there's iodine, and there's fluorine, and there's nitrogen, and there's oxygen. Well, the chlorine, bromine, and iodine, and fluorine, these are all in the same family. They are all halogens, and so they all have the same number of valence electrons. And so they all have 7 valence electrons. That's why these families are so similar, same number of valence electrons. And so the bromine and the iodine and the fluorine would all be just like this chlorine, where they're sharing 1 pair of electrons. So let's go on and draw oxygen. Okay, O2. Well, it has 6 valence electrons. If you look at your periodic table, you'll see that it has 6. There we go. All right. This oxygen, both of these oxygen atoms need 2 more electrons so that they each have an octet. And so what happens is they share 2 electrons. So now this oxygen sees a total of, wow, I didn't draw that circle around that. Sees a total of 8 electrons, go with that outer loop there. And then this oxygen also sees 8 electrons. All right, notice that, we're not adding electrons, but by sharing, and each of them sharing 2 electrons, we now have each oxygen having an octet in the outer shell. Now, that is what we call a double covalent bond. And most of the time you see it drawn like this with 2 lines there. So that double bond there would represent 4 electrons that are shared between the oxygen atoms. Double bonds are stronger than single bonds. It just kind of makes sense. And they're also shorter than single bonds because you're pulling a little bit tighter between the oxygen molecules. All right, let's look at our last diatomic molecule, and that is nitrogen. Nitrogen has 5 valence electrons. Okay, it needs 3 more. Let me redraw this one over here. What nitrogen is going to do is it is going to share 3 of its valence electrons to give us a triple bond. So now, see, this nitrogen is like, hey, I have 8 electrons, and this nitrogen is like, and so do I. But they're sharing 3 pairs of electrons. And so that is a triple bond, which is stronger than a double bond and stronger than a single bond, and it's also shorter than the double and the single bond. So N2 is triple bonded. All right, so covalent bonds, let's just summarize. It's when electrons are shared, it's between nonmetals, and we've looked at the Lewis structures of our diatomic molecules. Next video, we're going to start drawing Lewis structures, and we're going to kind of have some sets of rules for drawing these things. So, but right now, let's just know that single bonds are the weakest, triple bonds are the strongest, single bonds are the longest, and triple bonds are the shortest. All right, have a great night.